F-27B Nightingale. When imagination meets operational need, machines are born that can expose an enemy even in the silence of night. The F-27B Nightingale is such a hypothetical concept. The name itself hints at its role. Nightingale, the guardian of the night. Not only a watcher, but when necessary, a fighter. Below is a comprehensive, analytical, and practical commentary on this hypothetical aircraft. At a glance, what is it and why does it matter? The core mission of the F-27B addresses a prevalent demand on modern battlefields. Continuous intelligence, surveillance, and reconnaissance, ISR in low light and low visibility conditions, interception of enemy signals, SIGINT EW, and the ability to strike in a limited capacity when required. Adversaries often move under cover of night or bad weather, so a platform that combines all weather sensors, night vision, and weapons can be a highly valuable asset. Design and key features summary. Conceptually, the F-27B would be a medium-class airframe, either twin-engine or a highly reliable single-engine focused on endurance and payload capacity. Primary features would include SAR GMTI radar to detect movement through clouds or rain, EOIR gimbals for low-light imaging, a SIGINT suite, secure data links, and a modest internal weapon bay or external hardpoints. The avionics architecture would center on sensor fusion, edge AI, and hardened navigation to deliver reliable performance day or night and in adverse weather. How it operates in night and bad weather. Success in night operations depends first and foremost on sensors and integration. The F-27B would carry low-light cameras and cooled infrared sensors to produce imagery in near-zero light. SAR would allow the aircraft to detect ground movement through clouds and precipitation. Those sensors only reach full effectiveness when combined with robust sensor fusion and onboard processing. The platform would autonomously detect and prioritize targets, sending only actionable intelligence to ground command and control, reducing operator workload and speeding response. This is not meant to be a full-spectrum air superiority fighter. The F-27B is an ISR-first hybrid with defensive and limited offensive capabilities. It would focus on target designation, loitering support, and close air support assistance rather than taking a lead role in large-scale aerial combat. In short, more guardian than pure killer, but armed enough to conduct precision strikes when needed. Networked operations and survivability. Modern combat power comes from networks, not lone platforms. Nightingale's real advantage would be in its seamless, real-time data sharing with UAVs, ground units, and command nodes. Survivability measures, RWR, ECM, chaff flare dispensers, and IR signature management would improve its chances against air defense systems, especially during night missions. Those defenses depend on strong networks and redundancy to be effective. Development and practical challenges. The idea is attractive, but real-world development faces significant hurdles. Sensor fusion is complex. Edge AI must be validated and trusted. Reliable propulsion and domestic supply chains may be limited. The biggest challenges are cost and schedule. Starting with an ISR demonstrator reduces time and budget pressures. Moving to a multi-role or stealth variant dramatically raises complexity and cost. Typically, bringing a modern combat-capable platform to operational status takes years and hundreds of millions, if not billions of dollars, though a narrow-scope ISR platform can be fielded faster and cheaper. Legal, ethical, and political considerations. Persistent night operations and SIGINT collection can intersect with civilian communications and privacy, raising ethical and legal issues. International law, airspace sovereignty, and transparency must be part of program planning. Responsible oversight and legal compliance are essential if an ISR program is to earn public trust. Future upgrades and growth paths. Future upgrades could include optionally manned or fully unmanned variants. MUM-T, manned-unmanned teaming, capability to command swarms of smaller UAVs, directed energy defensive systems, loitering munitions, and AI-assisted targeting. A prudent approach is to build a proof-of-concept ISR demonstrator to validate sensors and data links, then iteratively add offensive, stealth, and autonomy capabilities. Conclusion: the F-27B Nightingale is a practical and logical hypothetical. There's a clear operational need for effective ISR in night and adverse weather environments, and a platform designed to meet that need could make a meaningful impact on future operations. Success depends on technical integration, strong network architecture, clearly defined mission roles, and responsible policy. If those elements are executed deliberately, Nightingale could become a trusted guardian of the night, an asset that sees and, when necessary, strikes to disrupt an adversary's plans.